Hello everyone. Happy to be here today discussing another exciting topic. But before I go deep on the topic, I think let me give a brief introduction. You already know myself. My name is Andrea Carcano. I'm the co-founder of Nozomi Networks, and today I have with me Ivan and Alessandro, both of them part of the security research team. But let them introducing themselves. Hi Alessandro.
Yeah,
Hi.
sure. Yeah, hey, hello, Andre. So let me just give you a brief introduction about the team. I'm Alessandro Di Pinto, and I lead the security research team, which is in charge to analyze new malware, producing protection about signatures for our threat intelligence service. Our most important mission is to keep infrastructure safe, not only for our customer, but also for the community. Today with us, we have Ivan from the security research team, who focused on the Dark Nexus analysis, and he will bring inside this session a very interesting technical insights.
That's great. Hi, Ivan.
Hi, Andrea. Hi, Alessandro. I'm new to the webinar, so hello, everybody.
That's great. That's great, Ivan. Welcome. And I'm excited about the topic today. We have a couple of deep technical insight to share, and as usual, we do that for two reasons. One is for sharing with you some of the research that we did, but also as usual, as part of our podcast series, we will also share and give the possibility to basically use some of the intelligence, some of the work that we identified with our research. So now let's go to the topic. I think Alessandro was mentioning that today the topic is related to botnet, and I think botnet is a concept that we already see, and we know that concept is very well defined for who is part of cybersecurity. So we're not adding anything new. But what is new today that we want to discuss and share is that we did a specific analysis to a particular botnet. And that is very interesting because according to me, it tells a lot about the evolution that in general the network is taking, and also the evolution that I see that all the different customers are kind of following. But before going deep, let me ask you a question to you, Ale. Can you give us like a brief summary about, just to make sure that we have all up to speed about what is a botnet and the definition of a botnet?
Yeah, sure. A quick introduction about the definition of a botnet. Basically, a botnet is a collection of devices which are infected by the same malware. And this botnet is usually managed by a single threat actor using a specific system to send data and commands to the bots called the command and control server. When we talk about IoT Botnet, we are talking about a collection of infected IoT devices. This is a very quick introduction about the botnet.
Yeah, no, that's great. And you just mentioned a botnet of IoT devices, and this is one of the key concepts that we're going to share today. We analyze Dark Nexus, and I let Ivan and Ale now add in more details, but we analyze Dark Nexus. That is a botnet that what's the difference between every other botnet. So we're going to go in deep. But what are the main difference that is a botnet that is targeting on top of standard devices, specific IoT devices? It's a landscape that is changing. And so Ale, curious to know a little bit more about what we discover about Dark Nexus and what's the difference.
Sure, yeah. We decided to invest a lot of time around Dark Nexus because basically it is a new IoT botnet which has been active during the last few months. We decided to jump into analyzing network behavior of this botnet because it is extremely important for protecting networks, because having indicators about how the botnet is talking with the command and control give us the possibility to effectively intercept the traffic, detecting it, and defeating the threat. So basically the infrastructure of this botnet is quite classic because it's based on a bot master providing commands to a large set of IoT devices that has been infected in the past. I'll let Ivan maybe to give us some insights about the capabilities of this botnet, like attack capabilities, proxies, persistent, and other insights.
Before go there in details on the capabilities of this botnet, just to to make sure that we have the right context. So basically, what we're saying here is that Dark Nexus is a specific botnet that is is an architecture not too much different from a standard botnet, but has some peculiarities, and one of those is basically targeting components that are considered the IoT components. Just to make sure that we give a brief definition. What is considered an IoT component? Is it correct if I'm thinking about a mobile device, a camera, or so on? Is that what you mean?
Yeah, absolutely. So essentially, for IoT device, we think about any device that has a TCP/IP stack on it and is typically embedded. So the average user doesn't have a console. Most of the time it's treated as a black box. You buy it, you put it in a network, and it just goes. Or sometimes you have to do some basic configuration. And it's a totally different environment compared to desktop. Let's say, in a sense, botnet are pretty much a solved problem on desktops because you have antivirus and point security solution that allow you to have a very deep observability of what happens in the machine. But on these devices, unless you monitor the network, you're pretty much blindsided. So this is the main difference. Very different environments.
Yeah. Ivan, before you go deep on that one, let me ask you a question. So it's easier today than to infected, and I think it's basically an assumption based on what you say. Is it correct to say that today it's easier to targeting IoT device, and basically get the control of that devices and adding that devices to a botnet compared to a desktop?
In a sense, absolutely yes, because the IoT devices are, as I said earlier, they are both plugged into a network and they just work out of the box. Sometimes they are even exposed to the internet. They even expose services that shouldn't be there, exposed to everybody who has a internet connection. So for instance, sometimes you find SSH or telnet servers running with default credentials on the internet. And this is a problem because sometimes when you actually read the documentation, you find about these things, but sometimes these are just debugging leftovers. So even if unless you perform a very deep assessment of the device before deploying, you don't even know what's running actually.
Yeah, yeah, so, sorry, Ivan, to interrupt you. Just to add a quick comment. This is super interesting, and I want just to mention an episode that recently I've been part of. So we were doing a project on a specific customer, and there was not an attack. There was not an attack in specific happening, but during the visibility part where we were discovering the network and we're helping the customer to get better knowledge about their plant and about their network. So we identified multiple cameras that they were part of a different network, so which is good. They were not part of the the OT network, so they couldn't communicate with the core of the plant. But all the cameras they have some exposure to internet, and the simple business case is that the management centrally, they want in specific to have the possibility to connect remotely to the webcam, to the camera that it was installed. Now the camera was unpatched. The firmware of that camera was pretty old, and there was some well-known vulnerability attached to that specific camera. So there was not any malicious activity. But that is an example how sometimes, and I know many of you in the webinar saying, okay, that is not the right way to do something like that. If I want my management to see the camera, I agree with you. But just for saying that this type of device sometimes they just requires a connection. And it is very easy to say, oh, wow, if I connect the device to internet, I can control that through my phone. I can do this. And then we forget that device then it's basically vulnerable to specific attacks. So that's just to mention and validate what you were saying.
Even because, if I can add a point, these kind of devices are coming plug and play, most of them. So you just have to attach the network cable and they're up and running. So for the user, it's not required any interaction for the security perspective. So of course, everyone can log in inside the web page, configure it, tune it, improve the security. But most of the users just plug and play it because it's the meaning that the vendor are selling the product, just for simplicity. It's fine, it's completely nice to have, but sometimes if a device is exposed in a protected network, it could be a problem. So this is another point.
Agree 100%. Now going back to the capabilities, Ivan, so what else we discover in doing the analysis of a Dark Nexus?
So essentially, how these kind of malware spreads, they typically use two different vectors. Either they go for a credential that are coded into devices. So typically a malware comes with hundreds of these credentials and they try each one until they find a successful pair, or they come with a remote exploit. Okay. Once a malware jumps into a machine, since these exploits and credentials are, let's say, over time, they tend to be shared across the malware developers community. What happens is that you might find somebody else already infected this device. So essentially, you have a race, a competition for each of these IoT devices. So the interesting thing about Dark Nexus is that once it gets to execute its code, it's going to profile the other processes that are running on the device. And when it detects, let's say, a suspicious process, it will try to kill it because it thinks that it is malware, another, let's say, competing malware family, and Dark Nexus wants to keep that resource for itself. So this is very interesting and pretty unique for at the moment.
Yeah, no, I can see, and that's raised me another interesting question. So, of course, in my past, even before Nozomi, I have the possibility to interact with some botnet or try to protect a network from specific attacks. Sometimes coming from a botnet, more sophisticated attack, a standard attack like a classical DOS attack, and so on. So. And I know even in the past there was some financial aspect, behind the botnet. I know that one of the reasons to create a botnet can be the one to perform an attack directly, or the one to create a weapon that can be sold, to someone in order to create a potential attack. And I found very interesting what you mentioned about fighting for getting a specific device. So I'm curious to get your perspective, Alan and Ivan, on the fact, is still there, this financial market around, attacker buying botnet for performing attack. And I'm curious to know a little bit more about your perspective about this war between different botnet for getting the control of devices.
Yeah, sure. During our analysis, we realized that basically the attackers who developed Dark Nexus basically have two chats on Discord and on Telegram, where let's say users can log in and can have the price list for renting the botnet. So basically you can decide, okay, for perform my attack, I just need 1 hour of the bandwidth offered by the botnet. So they can pay by Bitcoin. We saw also PayPal, so it's quite interesting that they are offering this service through PayPal. Basically, user can log in inside this chat and ask for this kind of service. It's unbelievable because actually it is a business model for the threat actors.
Oh yeah, 100%. And how is doing Dark Nexus compared to other network? Is already a gigantic botnet? Is a botnet that you believe is going to grow in the future? What's your provision?
So at the moment, Dark Nexus, based on our data, is not that big yet. But with the IoT botnets, what we actually should keep in mind is the development process behind it, because the number of devices fluctuates very widely, as we saw with Mirai. So it's just pretty much a matter of having a couple of exploits, very good exploits, and the number can go up very quickly. So yeah, you absolutely need to monitor all these kind of threats.
I can see clearly how new vulnerability came out, a couple of exploits as you mentioned, and then that number can grow exponentially. We saw that in the past, as you mentioned. So I think I completely can see that. So now we describe some of the stuff that we discover about Dark Nexus, right? We describe about this new botnet, but now let me ask you a question. What I can do now. I after this podcast, that I know that there is potentially also a thread of many of our IT components that I have in my network. So what I can do in order to check is, some of my components are part of this botnet, or eventually try to protect me and know and block this type of malware.
Yeah, sure. There are different ways that user can use to protect themselves and their networks. So the most important one, in my opinion, is to monitoring the traffic. Monitoring the traffic is incredibly important because this kind of botnets requires to connect back somewhere to the command and control. So understanding the protocols and understanding the ways these bots are communicating over the network, it's fundamental to detect them. In fact, during our last blog post, we released for free for the community a specific snort rule that will allow the users to protect their networks using tools like Snort. So everyone can use it, everyone can download it, it's for free, it's for the community, and it will for sure increase the safety in the networks. Second,
So sorry, no, Ale, please finish. Go ahead.
Oh yeah, no. The second, in my opinion, is it is extremely important to train users to increase the awareness about these kind of threats, because a lot of time threat actors are exploiting the users. So being aware about these behaviors. So, for example, limiting the internet access to those devices that doesn't really need to be exposed online, we will increase the safety level over the world. I mean, so if everyone is aware about that, I think we can all together bring the level higher.
Yeah, no, that's great. That's super interesting. So you mentioned, one of the rules that we release is part of our community. So just to mention, you can find that, go in our blog. You will see a more detailed analysis about the botnet. You can download that rules. As you know, we keep maintaining our GitHub page for the entire community. Still the link on our website. And you can use multiple tools for digesting the rules. That intelligence is there, is part of the community. And of course, one of the tools that can be used is our community edition that is free. But as I said, our goal here is just try to keep doing something and helping the community. So guys, that was a very, very interesting discussion. Before move ahead, I would like to ask you a very last question. And I see already some question coming, and it's more a question related to the future. And so in specific, assuming that you can predict the future, so we introduced now specific new botnet. I already even spoke a little bit about the fact that potentially in the future can grow much more. But if you need to have a provision, right, what's your take on the evolution of the botnet itself, considering a landscape that is changing, right? 15 years ago, I don't think my phone was able to have an IP address, and now it's completely different. So what is your take?
Yeah, I think that we are exposing in internet a lot of new devices, IoT devices, sensors, cameras, all these kind of devices can be compromised. So I think that in the future we will see a lot of increase in this kind of attacks. So it is extremely important to take countermeasures, introducing new protection systems, security levels, monitoring the traffic, increasing the awareness, because in the future, for sure, this kind of attacks we will increase.
Yeah, I agree 100%. Ivan, anything to add, or you're pretty much aligned with the provision of Ale?
Yeah, I agree with what Alessandro said. I also think that as far as the vendor are concerned, they should do something better as far as patch management, and they might even try to look at the desktop world and how they cope with security. Because if we think about 20 years ago, security on desktops was nowhere as good as today. So yeah, there is a lot to be done. There is also a clear path ahead.
Yeah, no, I completely agree with you. I completely share the vision, and I think as you mentioned, phone, they were completely unpatched and unsecure as soon as they show up in the network. I remember very basic vulnerabilities on one of the first smartphone that came out, and now the level of security around that type of device is increasing. But what is happening right now, as you mentioned, is that we have lots of new devices that are kind of facing the very initial phase of, I have an IP address, you can always reach myself. I think I was watching the other day, device like, even home devices like, basic device are now accessible, and they could have an IP address. So that's I agree with you. There will be, we need to monitor that type of space. So I think we cover, more or less the main characteristic of this botnet. I think we discuss about, some of the countermeasure that we can take and how we can better monitor our network. So thank you for that. One of the things that we want to do more now is, do like a little bit of a deep analysis, and I know you guys prepare something. So I let you, Ivan, share what you prepare.
So we have a couple of interesting video for you today to showcase some of the capabilities of Dark Nexus. The first one is about the propagation. So we will show one of the techniques that Dark Nexus uses to propagate itself. While the second one is about one of the attacks that Dark Nexus can perform. So I'd just like to briefly mention how we treat this kind of samples when we receive it. So the first thing we do with IoT malware is we do some static analysis in order to understand broadly what a sample can do. And then later we prepare, we have an emulator specifically for this kind of malware that we use to run the sample on. Also, another interesting activity that we do is that we have a simulated internet that we plug into the emulator, so that when the malware runs, we want it to believe that it's running on a real device, in order to see what it does, the kind of service it's looking for, the kind of exploits it's trying to run. So the first video is about telnet propagation. We have a split screen here. On the left, we have a console that is the console of an IoT device where we will launch the sample from. And on the right side, instead, we have a telnet monitor. Essentially, when Dark Nexus starts, it starts scanning random IPs for telnet servers. In our simulated internet, we expose several telnet services, and randomly, once in a while, we accept the credential that the malware is sending to us, and we print the credentials on the screen here in the monitor. So essentially, the reason why we do that is we try to the best of our possibilities to trick the malware into believing that it's running on a real internet. If we set up every telnet server that will accept every credential, the malware might even try, and we saw it in the past, to fingerprint the environment before running in order to understand whether it's running in a simulated environment or in the real internet. And while here we see just very few credentials, on the network side, there is a lot of activity going on. Obviously, if you don't have a network monitoring solution, it's not something you can be aware of, and you can be utterly blind to this kind of activity.
Yeah.
So this is the first video.
Yeah, that's super interesting, Ivan, and I think it show some of the strategy behind the virus. As you say, the virus is really trying to get access to all the different devices. So by having a tool that is monitoring the traffic, you can pretty much identify some of that connection. And I'm asking you, why is possible to identify it? Is the malware using a specific pattern in the way that it's communicating that we're able to reproduce? Or is this more like because by having some baseline, we basically see some anomalies on someone scanning my network?
Both the things actually. So there is of course some anomaly as far as network traffic goes, because we see an IoT device making a lot of telnet connections with different credentials to different IP in a very short period of time. This is obviously an anomaly. Also, the other thing is that we see IoT device that typically receive, they are on the server side rather than on the client side as far as a telnet connection is concerned. And the other thing is that this malware also does some other kind of traffic on weird TCP ports that obviously they stand out if you have a network visibility.
I can see. So what else you prepared for us, Ivan?
So we also have a very interesting second video where we are showcasing the attack capabilities of Dark Nexus. So this scenario is a little bit more complicated, but it's going to be very straightforward when you think about it. So essentially here we have three consoles. The first one is the target that is running a web server. This is going to be the target of our bot. The second screen is the server that is used by the bot master to commandeer, to manage the whole botnet. And the third one is the IoT device that is infected with with Dark Nexus. The first thing that we need to do in order to run this example properly is we need to start the CNC server so that we can tell the malware what to do. So we start the server, and then we proceed in infecting our IoT device. As soon as we start the malware, we see that it already connected back to the mothership. And in the CNC server that we customly wrote, we can see that we have a series of commands that we can specify. And then we see on the target web server that we don't have a lot of connections so far. But as soon as we specify the target, we see that immediately our infected device starts sending thousands of requests to the victim machine. And the idea is essentially to overwhelm the web server until the denial of service is completed. So obviously, this is just running our simulated internet with just one device. But if you think about it, what happens in the real world, you have thousands of devices hitting a single victim at the same time. So this is what happens in the real world.
Yeah, that's super interesting, and I've been part on trying to fight some DDoS attack in the past, coming from different sources, including botnet. So it's always an interesting challenge when you are on the other side and you try to protect that. So now first of all, before I ask you some question, let me make sure that we open up for question to everyone that is part of the webinar. So feel free to ask us any question, any curiosity that you have, around the network and around what we discussed, or around the botnet that we just presented. So any question is more than welcome. So we have an initial question that is coming, was done before, and is related to the fact that we described that Dark Nexus is mainly targeting IoT components. So do you think that the power of a botnet is exactly the same, even if sometimes the IoT components have low computational power, or they have limited capabilities compared to a standard desktop. There will be some differences. What is your opinion here?
Yeah, here the key point for this kind of threats is the bandwidth. So basically, it depends by the bandwidth of the network where the bot or the IoT, the infected IoT device is in. So if inside that network there is a really large bandwidth, it will make it very effective during the attack. So it's not so important the computation power of the machine itself, but how fast he can send packets outside the network. So it is a key factor in this kind of attacks.
Yeah. Another thing is that if we compare it to the typical bot that infected the desktop, if a user is actually using the computer, it will notice something's going weirdly, the network is low. But in these devices, the user doesn't have visibility most of the time. So unless something catastrophic happens, like you have a camera and you don't see the image anymore, the user doesn't even know. So the attacks continue in the background.
Yeah. So I think we have a question coming you know, from one of the person in the webinar, and another question coming from Theodore. Hopefully I'm pronouncing correctly your name. Is once we found an infected device, how can I clean it up, that device? So I use one of the rules. I may use the community edition of Nozomi or another tool and identify that 6 of my camera are actually part of a botnet. What is the next step?
So the first thing is, well, unplug the device from the network. That's step one. Second step, understand the firmware version that is running on the device. Check with the vendor whether there is an update. In case an update is available, apply the update. And the really interesting thing is understanding that, try to understand from the network traffic how the malware jumped into that device in first place, because it could be a 0-day, it could be even a 1-day exploit, but the firmware, the last firmware that the vendor is supplying might not even cover for that case. So you need to do some kind of technical work. And I think that because you need a lot of interaction with the vendors, is really important to carefully vet a vendor before committing to a solution, because this is going to hurt you if you don't.
To add something here, Ivan, also based on my experience, I agree completely with you. You know, the very first initial step, if we identify something like that, is okay, let's unplug the device, if I can unplug the device. The second one is, if I cannot unplug the device, do I have a network infrastructure that can give me the possibility to shut down that connection? So you know, adding a rules on the firewall, making sure that I manually add some rules in order to block that type of device is another, you know, workaround. And then as you know, third step, as Ivan said, is okay, let's see, first of all, very simple, do we have an updated firmware for that device, firmware, software, or so on. So in my experience, you know, botnet are really trying to tackle a gigantic number of devices. So they may have a 0-day, as Ivan said, but in many cases they get a lot of advantage just by using well-known vulnerabilities, especially here for IoT devices, because IoT devices are not part of the patch management yet. So it's so you know, sometimes they're just there. Yeah, I installed that. It was the other group, the physical cybersecurity. We have a badge access, we have cameras and so on, and they are kind of outside from the IT control in some cases, and there is no patching, you know, cycle there. So maybe that's the first one. So by installing a patch, we actually, you know, discover that we're going to fix some of that vulnerability. And on the last topic, if all these topic didn't solve, all these steps didn't solve already the problem, I think as you mentioned, guys, the last step will be, okay, let's try to analyze the traffic, because maybe that is more sophisticated and we have a 0-day there. And again, if I block the traffic going outside and I kind of segregated that device, I already did part of the job. But still, I may have my device still vulnerable, so I want to kind of curate the problem from from the bottom. So that is my take. I don't know, Ale, if you have anything to add.
No, I think more or less it's correct. Well, it is correct, but I think I don't have any other points. Maybe to change the default password, because it is a common technique using during the attacks. So they are brute forcing, as we show in the demo. So soon after the installation of a new device, I strongly suggest to change all the default passwords, because if the attacker is not so sophisticated to use a 0-day, it will try for sure to access it with the default password. So keeping it in the to-do list after an installation, it is a good point, in my opinion.
Yeah, I agree. And there is a very good comment that I really like it from Miroslav, that is saying, yeah, so he's basically saying that's why 5G networks can be a disaster, considering, you know, the amount of new IoT devices that are, introducing themselves to the network. So of course, 5G can provide a kind of a constant connectivity on a public network. So, you know, that can become a gigantic problem, which I totally agree. So I don't know if you have any comment here, even on Ale, on this one, but personally, I agree.
I completely agree with that. Yeah.
Yeah. So we have another question from Michael. Michael is asking, any IoT device can be infected, any IoT device, and what we can consider. Now I'm asking this question, what we can consider an IoT device? And the question for Michael is, any IoT device, IIoT device can be infected as well.
Okay, go Ivan, you can.
So absolutely, essentially, the definition of IoT device can be blurred sometimes, but at the end of the day, it means that it's running, let's say, pretty standard operating system like an embedded Linux or VxWorks or something, let's say, which has they have a standard API where a developer essentially can develop a binary for. So as long as there is a TCP/IP stack development platform for, this is going to be a target.
And sorry to interrupt you, Ivan, because there is another comment that came out in the meantime. So the comment was, saying, coming from John, saying, you mentioned a lot of time IoT, but, you know, IIoT are exactly, so industrial IoT are exactly, part of the same problem. So, and I think the answer is yes, but I'll let you guys add more color.
Yeah, the answer is yes. Specifically talking about Dark Nexus, Ivan, correct me if I'm wrong, I didn't see any specific attack or strategy for those devices. But of course, if one of those devices come with a default password, the attackers can just create an update to infect also that kind of devices. So yes.
Yeah, absolutely. I mean, the vectors are there. So the possibility is there. As long as there is, let's say, a strategy to monetize a kind of attack, that attack will be done.
Yeah, I agree. I agree 100%. And based on all the experience and all the time that we're spending right now with customer on plans and so on, one of the beautiful things that I see, I started to do cybersecurity and industrial control system long time ago. Even before my PhD started, that was focused on that. And I see, especially in some sector, a gigantic evolution in all the plant and all the OT network, and the IIoT components are part of that, right? We can use some base word like plant 4.0, industry 4.0, and stuff like that. But the reality is that the way that we're even monitoring a power plant 15 years ago is different from the way that we're doing that now. Aside on the evolution that is happening on the SCADA components itself. But there is so many other components that are part of the picture now that are making the process better, more efficient. But on the other side, there is a lot of components there now that are potentially vulnerable, and they're kind of outside from a standard IT strategy for patching. But also they're not a classical OT components that sometimes they especially in the last few years, they gain an extra attention. So I think because of this issue, we can potentially we can really see this type of device part of a botnet blowing very soon. So that was a great conversation, Ale and Ivan. I think we don't have any other question. I want to just do a quick summary with you about what we discussed today as some of the main takeaway for who was part of our webinar today. First of all, I want to say we did a webinar, but we are doing that because we want to share some information, make aware the community. So our webinar will be online. So in specific, you can listen also the podcast of this webinar. So if you have some colleagues or some specific a friend that you think they should benefit in listening what we discussed today, you will have a shorter version of our discussion as a podcast available in all the majority of the podcast platform. And before I tell you some of the other references, let me do a quick summary, and then we go on the other resources that we have available. So we discuss and we introduce a new botnet that is a new botnet focused on IoT and IIoT components. We discuss about the potential evolution of this botnet, and we also make available for all our community a specific rules in case you want to quickly check in your network if you have some indicators that some of your devices are today part of this botnet. So as we mentioned, everyone can use it. And in specific now, let me go on the resources side. So there is the blog. So go and read the blog if you want to get some more details. We have a dedicated web page where you can go and you can download what was available and that we discussed today related to Dark Nexus. But everything that we did during COVID-19 and before is available there. So you can download it. You can access. You can find the link of our GitHub page, and you can basically download everything that we created and we share with the community. And I mentioned, of course, the podcast. So here you will see the link, but I want to ask Ivan and Ale if you have anything else to add as a conclusion.
I think you did an excellent overview.
Did I forget something?
Yeah, Andrea, awesome.
That's great, guys. Was fantastic discussing with you about this topic. I think is very interesting. So looking forward for chat with all of you soon on our next topic. So, and for today, thank you so much, and I wish you a great day or a great evening based on where you are right now.
Thanks.
Thank you.
Thank you.
Thank you, everyone.